You're welcome. You're welcome. Let's continue on with the review then for Workplace 30, Workplace and Apprenticeship 30 Math. Chapter 4. So this is a review for Chapter 4. We're talking about probability and odds. Okay? Very, very different, although they're very, very similar. Okay? When we're talking about probability of something happening, or what are the odds of something happening. Very, very similar. Let's talk about experimental probability first. So in 4.1, we talked about experimental probability. And one of the things that you have to learn how to do is simplify fractions. If you have a calculator, you can use your calculator typing in the fraction and then hitting your fraction button. Okay? For most calculators, that's going to work to simplify the fraction. All right? If you have to show your work to simplify a fraction, so let's take a look at this 32 over 48. What you want to do is you want to pick a number that can divide evenly into both. So let's say I pick 2, because I know that both those can be divided by 2. That's going to be 16 over 24. It just so happens that I can keep dividing this by 2, or I can keep reducing. And so I'm going to divide by 2 again, and that's going to be 8 over 12. Well, I can keep going, or I could kind of get smart here and pick the largest number that will divide into both of these evenly, and that's how I can get to my very simplest form. So if I take 4, I get 2 over 3, right? Now on your, is that right? Did I do that right? Okay, I thought someone was correcting me. It's all right. So watch this, 32 divided by 48. Now with a graphing calculator such as this, I don't have just a simple button you can push, but if you try this on your calculator, push your fraction button, which is like A over B or something like that, then it should show you your simplest fraction. Now for me, and you guys might recognize this, 0.6 repeating, you should know that that's 2/3. Yes. So you could maybe see this decimal and say, hey, I know that fraction, it's 2/3. Now in this calculator, you can hit this math button and then answer to fraction. If you hit enter, then it'll show you 2 over 3. So the calculators can help you with reducing fractions. What is experimental probability? Experimental probability is, and I will get to the definition here right away. These are just more work with fractions, which I'll come back to. Okay, I will come back to that because it's important. But let's talk about what a probability is and what experimental probability is. So probability is the chance of something happening, and it's the number of occurrences of that event or of something, whatever it is you're talking about, the number of times it actually happens divided by the total number of times that everything can happen in that situation. So for example, if we're talking about rolling a die, a regular 6-sided die, what's the probability that you'll get a 2? Well, if you roll, there's 1 2 out of a possible 6 numbers, and all are equally likely. So it's just random. It's 1 out of 6. That's your probability. Experimental probability is a probability that is based on experiment, which means if I rolled a die 50 times, or 100 times, let's say, and let's say I got a 2 10 times out of 100, my experimental probability would be 10 out of 100, or 1 out of 10. Now, is that the theoretical probability? So if I actually rolled and I got 1 out of every 10 was a 2 that showed up, is that the same as 1 out of 6? Well, this would be your experimental probability, and this is something, and because you've been through this chapter, you might know what this one is. There we go. Very good. Theoretical, okay? So this is the theoretical. Now the theoretical says what should happen, all things considered equal, and if you were to experiment with this an infinite number of times, then the experimental probability would be equal to the theoretical. But because we're only taking a small sample of these, or a small number of occurrences, our experimental probability might not be the same as the theoretical. And it may indicate other things are going on, like maybe there's a problem with the die or something, maybe. But obviously 1 out of 10 and 1 out of 6 aren't the same, and they don't have to be the same. So that's experimental probability. I'm gonna kind of quickly go past the converting fractions and decimals. We can take a look at that a little bit later if you want. But you should know also what a sample is, right? A sample is a selection of a larger population. So if I was talking about grade 12 students in the country and I selected you guys would be a sample of the larger population. Not the whole population, you guys aren't everybody, but you're a sample. Now, in order to choose samples, that's a different topic altogether, but you, in order to choose a suitable sample that would represent the population, you might not want to take, a few people from one school, or a few people that have a lot of common interests, or that live in the same city or whatever. You might want to select a sample from various parts of the country and things like that. But that's what a sample is. And if we're talking about sample size, the larger the sample size, the more accurate the results. Okay? So oftentimes we work with samples to find out information about the larger population. Okay. So that's a little bit on sample size. 4.2 talks a little bit more about theoretical probability. And so as I mentioned before, the theoretical probability is the expected probability given the nature of the situation. It doesn't have anything to do with actual experimentation. It's just based on the nature of the situation. So for example, if I rolled a die and I rolled a die 6 times, you would guess that one of those times should be a 2, or one of those should be a 5, or one of those should be a 6. Now that's not going to happen. If you roll it 6 times, you're not going to get a 1, 2, 3, 4, 5, and 6. Probably. But theoretically, that's what should happen. Every 6 rolls, you should get the same number as you rolled already. Based on the nature. If you flip a coin, what are the chances that you get tails? Well, yeah, 50%, exactly. There's only 2 options, and tails is one of the 2 options. So your theoretical, that means kind of your idea about this probability, what should happen, theoretically, is that it's 1 out of 2. So you should have a 50% chance of getting that. Okay? Now what does this say? The ratio of 1 or more events of interest in the total number of possible outcomes. Okay? I like my version better. Okay? The expected probability based on the nature of the situation. I think you guys understand that. When we're dealing with cards, maybe something to remember for your test and things like that. If you don't know cards very well, there are 4 suits. Okay? The 4 different types of cards. Hearts, diamonds, clubs, and spades. Those are called suits. There are 4 of them. There are 13 cards in each suit, making 52 cards in a deck. All right? 2 of those suits are black and 2 of those suits are red. Okay? I don't know what else you need to know. But if you were calculating the theoretical probability of drawing a heart, then that would theoretically be 13 hearts out of 52, or 1 out of 4. Okay? Right? Oh yeah, face cards as well. You need to know about face cards. So the jack has an actual face on it. The queen and the king have actual faces on them. So there's 3 face cards. The 2 to 10 don't, and the ace don't. So yeah, sometimes ace, yeah. Sometimes students get that mixed up too. Okay. Any other questions about cards that you're unsure of that you think we might need to know for the test? I guess there a lot of the information right here, and honestly, I didn't even see that. But you can read that. You can read that a little later. So, all right, odds and probabilities. So that's probability. Let's talk about odds now. And again, they're very different. You don't hear about odds as much as you hear about probability, but odds is the ratio that compares a desired event to the number of undesired events. So now, listen very carefully. The probability from before of rolling a 2 when I roll a standard die is 1 out of 6, because there's 1 favorable and there's 6 total. Well, in odds, we never write down the total. The total is not in odds at all. It's desired outcomes versus or compared to undesired. So the odds of rolling a 2 would be 1 to 5. Very good. 1 to 5. Because there's 1 2 on the whole die, and there's 5 other ones that are not 2. Okay? So the odds in favor of rolling a 2 are 1 to 5. Now, the other kind of odds are odds against. So what are the odds against rolling a 2? Well, that is the ratio of undesired outcomes to desired outcomes, or 5 to 1. 5 to 1. Okay? Okay, any questions about that here so far? All right, so that's a question that we just kind of did with number 2. This is the example here, is talking about rolling a number 6. Okay, so you can look at this example if you want. It's very, very much the same, exactly kind of what I just ran through here. Okay, so this one here, I'd like to go over this just to round off this this instruction here about odds and stuff. So complete the following chart. Okay. So rolling an even number with a six-sided die. All right. So with a six-sided die, we know that we have 1, 2, 3, 4, 5, and 6, right? So the even ones would be 2 and 4 and 6. So rolling an even number with a six-sided die. The odds in favor would be 3 favorable outcomes to what? How many unfavorable? Well, that would be the odd ones, which there are 3. So it's 3 to 3. Or you could say 1 to 1, because we can simplify odds, an odds ratio, the same way we can simplify a fraction. Okay? So 3 to 3 is the same as 1 to 1. 2 to 4 is the same as 1 to 2. You can simplify. Okay? So what are the odds against? Well, what are the undesirable? 3, 2, 3, or 1 to 1. So the odds in favor and the odds against are the same. If that's true, the probability is 50-50. So 3 out of 6, or 1 out of 2, or 50%. Okay? Now, let's take a look at the number 2, and I think I might have to bring the dice table in for question number 2, or row number 2. Rolling doubles with 2 dice. Okay, so I'm going to go back to this table right here. So what are the chances of rolling, oh, can I get those all in the screen? Sorry, make that all small. So if I look at the dice table, this is, if I had 2 dice, 1 to 6 and then 1 to 6, here are doubles right here, right? So it's asking about doubles. So how many options for doubles do I have? It looks like 6 here. And what's the total number of rolls here in this table? 36. So it looks like it's 6 out of 36. Or if this question is actually asking about, where is it? Odds in favor, rolling doubles. Okay, let's go back there. So this is probability. So the odds in favor are going to be 6 to... Not 6 to 36, no.
36 to 35.
36 to 35.
To
Ah, there we go.
My brain is there.
6 to 30, right. Because if we were to take the time to count all these, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 30. I don't know where my counting went there. I kind of lost track of what I looked like I stroked something off twice. So anyways, trust me, there's 30. Okay. So 36 minus 6 is 30, right? So we take those 6 away. So odds in favor 6 to 30. The odds against rolling doubles. Odds against. I'll write that as fast and as messy as I can. Well, it's 30 to 6. Okay? Odds against. Yes, yes, yeah. If we simplify that, this would be 1 to 5. Well, I don't know, what did you say? 2 to 15? Yeah. If we divide both these by 6, we get 5 to 1 here, right? Yeah. So 1 to 5, 5 to 1. Yeah, that would be the simplified. Or 3 to 15, maybe. Okay, any questions about that? Those are good questions. All right, let's see, is there, okay, let's talk about the cards then. Drawing a spade from a deck of cards. So remember, there are 4 suits. Spades are one of the suits. So odds in favor would be there's 1 spade and there's 1 spade suit and there's 3 other suits. Remember, odds, we never put the total in there. Never the total. It's good to bad. Okay? So what are the odds against? Well, so for not doing a spade, well, there's 3 others than spades, and there's 1 spade, so 3 to 1. Probability is, now this is where you have favorable divided by total. So 1 suit divided by the 4 suits. Or 25% exactly, yeah. Okay, you guys getting it? Okay, what about this one? Drawing a 5. So a number 5 can be from any suit. So how many 5s are there in a deck of cards?
4.
There are 4. Okay. So if we're talking about odds in favor, There are 52 cards in total. If you take 4 of them out, how many are left that are not 5s?
48.
48 is correct. And simplified would be 1 to 12. Very good. Okay. And there's 1 5 in each suit. So that means there's 1 5 and 12 that are not 5s in each suit. And that would be your reduced form. Right on. And again here, 12 to 1. And then this is 5. Okay, so let's say there's 5 out of 52. Right? Drawing, sorry, 5. 4 out of 52. Whoa, where's my screen going? I know. Wacko, hey? Sorry, 4 out of 52, or 1 out of 4, or 25%. Okay, look at, I have numbers just disappearing. Okay, any questions? I'll go over number 3 real quick here for you. This is one last odds probability question. For a charity raffle, 1,000 tickets were sold as a fundraiser. The odds against winning a prize are 199 to 1. So in a question like this, what you're going to want to do is make sure that you kind of got things straight. Write things down. Make sure you're organized in your head and on your paper. So the question says, how many winning tickets are sold in total of 1,000? Well, we take this. This is what we're given, really, right? The odds against winning are 199 to 1. That means the odds for winning are 1 to 199. So that's what I wrote down first. It's like, okay, let's get odds for, which means that there's a total of 200 tickets, because there's 1 winning one and 199 that are not winning. So the chances, how many winning tickets are there? The probability is 1 over 200. 1 out of 200. And if there are 1,000 tickets, this is the way I did it. I understood that, hey, 200 times 5 gets me 1,000. So 1 times 5 would be 5. Or you could write it like this. If there are 1 out of 200 that win, then that has to equal how many out of 1,000? And of course, you just cross multiply, and we have 1,000 divided by 200, which equals 5. However you want to do that. So odds versus probability, a huge thing in this chapter. I hope you understand that now. Any questions? Okay, so odds, odds and probability, theoretical probability, experimental probability, and yeah, if you want to take a look at this chart just for the last half a minute here in this video, and this little instruction, you can. Changing fractions to decimal is as simply as dividing on your calculator, and a percentage, you take your decimal, whatever that is, and you multiply by 100. Okay? And you can work backwards the other way too. So if you have a decimal, multiply by 100, and you can write that as a fraction. So you want to remember that's 0.70 is the same as 70 out of 100, or 7 out of 10. 12%, if you work backwards, that decimal is 0.12. That's 12 out of 100. Or we divide that by 4, maybe 3 out of 25. Okay. Any questions from you grade 12s about this? All right, there's your review.